Hi everyone. Today we're going to study displacement and average rate of change. First, let us define displacement. Let S equals f of t represents the function of a moving object, say a car. The displacement of the object over the time interval from A to B is delta S equals f of B minus f of A. Let us see this example. Find the body's displacement for the function S equals t squared minus 3t plus 2 given time interval where t is from 0 up to 2. For our solution, let us write the formula for the displacement. We have delta S equals f of B minus f of A. With regard to the given time interval, we will now write here delta S equals f of 2 minus f of 0. We know that this number 2 here comes from the end number of the interval, while the 0 comes from the initial number of the time interval. Now, let us evaluate f of 2 and f of 0 given this function here. Let's begin with f of 2. So we have 2 squared minus 3 times 2 plus 2. Simplifying further, we have this 2 squared to be 4 minus 3 times 2 is 6, then plus 2. So 4 minus 6 plus 2 is equal to 0. Next, let us evaluate f of 0. So we have 0 squared minus 3 times 0 plus 2. This 0 squared and the 3 times 0 will only be 0. So our f of 0 is equal to 2. Let us substitute the corresponding values in here. So our delta S now becomes 0 minus 2. And our final answer is negative 2. This is our delta S, and this is the displacement in this problem. Now, let us define average rate of change. The average rate of change, or the average velocity of the object, defined by S equals f of t over the time interval from A to B, is we have delta S over delta t, and this is equal to f of B minus f of A all over B minus A. Let us see this example. Find the average rate of change for the function f of x equals x cubed plus 1, given time interval from 2 to 3. For our solution, let us write the formula of the average rate of change. With regard to the given function here, we will write here delta y over delta x is equal to f of b minus f of a all over b minus a. With regard to the given time interval, we will write here now f of 3 minus f of 2 all over 3 minus 2. Let us now evaluate the f of 3 and f of 2 respectively with regard to the given function here. Let's begin with the f of 3, and this is equal to 3 cubed plus 1. This 3 cubed is equal to 27 and then plus 1, so the final answer is 28 for the f of 3. For the f of 2, this is equal to 2 cubed plus 1. Our 2 cubed is equal to 8, then plus 1, and the answer is 9 for the f of 2. Let us now substitute the corresponding values in our formula here. So the f of 3 now becomes 28 minus the f of 2, which is 9, all over the 3 minus 2 is simply 1. 28 minus 9 is equal to 19. We will not write the denominator 1 anymore. So this is our final answer. This is the average rate of change for the given function. Hi everyone. Today we're going to study velocity and acceleration. First, let us define velocity. Velocity, or instantaneous velocity, is the derivative of position with respect to time. If the body's position at time t is the function s equals f of t, then the body's velocity at time t is v of t equals ds over dt. That is the derivative of this function. In relation to the average velocity, we write here that the velocity is equal to the limit of delta s over delta t as delta t approaches 0. So this is equal to the limit of the function f of t plus delta t minus f of t all over delta t as delta t approaches 0. Now, speed is the absolute value of velocity. So the speed is equal to the absolute value of v of t, and this is equal to the absolute value of ds over dt. There are some notes here that we should remember. Number 1, when the object is moving forward, we say that s is increasing. Then the velocity is positive. Next, when the object is moving backward, or we say that s is decreasing, then the velocity is negative. Now, when the object is at rest, then velocity is 0. Now let us define acceleration. Acceleration is the derivative of velocity with respect to time. Thus, we write a of t. A here stands for acceleration. This is equal to dv over dt. We take the derivative of the function of velocity. Or we say that this is d square s over dt square. This is the second derivative of the function s. There are some notes to remember also. Number 1, when the object is slowing down to a complete stop and the original velocity was positive and decreasing to 0, then the acceleration is negative. In other words, if the velocity is positive and decreasing, then the acceleration is negative. Next, when the object is slowing down to a complete stop and the original velocity was negative and increasing to 0, then the acceleration is positive. In other words, if the velocity is negative and increasing, then the acceleration is positive. Let us see this example. Find the body's speed and acceleration at the endpoint of the interval. The function is s equals t squared minus 3t plus 2. And the interval is t is between 0 up to 2. For our solution, let us compute for the speed. By the way, we know that the speed is the absolute value of velocity. Our formula for velocity is v of t equals ds over dt. That is the derivative of this function. So we have the derivative of t squared to be 2t, then minus the derivative of 3t is 3. The derivative of 2 is 0. So we have here 2t minus 3. Now at t equals 2, this 2 is the endpoint of the interval. Let us evaluate the function v at t equals 2. So we write v of 2 equals 2t now becomes 2 times 2 minus 3. So we have 4 minus 3 equals 1. Since velocity is positive and the absolute value of positive 1 is 1, so we write here the speed equals 1. This is our final answer. Now for acceleration, we write a of t equals the derivative of the function v. So derivative of 2t is 2, derivative of negative 3 is 0. So dv over dt is simply 2, and that is a constant. Evaluating the function a when t equals 2, and we know that this 2 comes from the endpoint of the interval. So we write a of 2 is equal to 2. This number 2 here is simply the value of the derivative, which is a constant. This is our final answer. We have the acceleration to be 2 and our speed is equal to 1. Hi everyone. Today we're going to study more sample problems for velocity and acceleration. First, let us make a short review for velocity and acceleration. Let S equals f of t represents the function of a moving object, say a car. Velocity, or we say instantaneous velocity, is the derivative of position with respect to time. So we write here v of t, where v stands for velocity. And this is equal to the derivative of this function. So we write here ds over dt. Now, acceleration is the derivative of velocity with respect to time. So we write a of t, where a stands for acceleration. And this is equal to the derivative of this function. So we write dv over dt. Or we say that this is the second derivative of the function s equals f of t. Let us see this example 1. At time t, the position of a body moving along the s-axis is s equals t cubed minus 6t squared plus 9t. Letter A, find the body's acceleration each time the velocity is 0. Letter B, find the body's speed each time the acceleration is 0. For our solution, let us find first the velocity, and that is v of t. This is equal to the derivative of this function. So ds over dt equals 3t squared minus 12t plus 9. Next, let us find a of t. This is the acceleration. This is equal to the derivative of this function here. So we have dv over dt equals 6t minus 12. Now, let us solve for problem A. The step 1 is we're going to set the velocity function equals 0 and solve for t. So this function here now becomes 0 equals 3t squared minus 12t plus 9. We can see here that the terms of the right side have common factor, that is 3. We can factor out the number 3, so we have 3 times the quantity t squared minus 4t plus 3. If we're going to divide the equation by 3, this equation is simplified into 0 equals t squared minus 4t plus 3. Now, let us solve for t. we can see here that we can solve this by factoring. So we write 0 equals the quantity t minus 3 times the quantity t minus 1. Let us equate both factors to 0. So we have the t minus 3 equals 0 and the t minus 1 equals 0. Solving for t, we have the values t equals 3 and t equals 1. These are the values of t when velocity is 0. Now, for step 2, we will evaluate the acceleration function at t equals 3 and 1. These are the values that we get from step 1. Let's begin with a of 3. This is equal to 6 times 3 minus 12. The 6 times 3 gives 18. Then minus 12, we have 6 as the answer. Next is a of 1. The same function that we will use, and this is now equal to 6 times 1 minus 12 equals 6 minus 12 equals negative 6. So we have the answers for letter A. Let us write the answers below the problem A. So we have a of 3 equals 6 and a of 1 equals negative 6. Now let us solve for letter B. This time we have step 1. Let us set the acceleration function equals 0 and let us solve for t. So we have 0 equals 6t minus 12. Solving for t, let us transpose this negative 12 to the left side. So we have now 12 equals 6t. Isolating the t, let us divide both sides by 6. So we have 12 over 6 equals t. So the value of t equals 2. This is the value of t when acceleration is 0. Now for step 2, let us evaluate the velocity function at t equals 2. This value 2 is what we derived from step 1. So we have now v of 2 is equal to 3 times 2 square minus 12 times 2 plus 9. Simplifying this, we have now 12 minus 24 plus 9. And the answer here is negative 3. Take note that we are looking for the speed. And the speed is equal to the absolute value of velocity. So taking the absolute value of negative 3, the speed is equal to positive 3. Let us write this answer down the problem B. We are now able to write the final answers for example 1, problem A, and problem B. Let us see example 2, at which time t, the average velocity equals the instantaneous velocity of the moving particle s of t is equal to t square minus 3t plus 2 over the time interval from 0 to 2. For our solution, we will equate instantaneous velocity and average velocity and solve for t. So we will write here ds over dt equals f of b minus f of a all over b minus a. Take note that the ds over dt is the instantaneous velocity, while the right side here is the formula for the average velocity. Now, with respect to our time interval, the right side of the equation becomes f of 2 minus f of 0 all over 2 minus 0. Let us evaluate both sides of the equation. ds over dt is the derivative of our function. So we have now 2t minus 3 is equal to, the right side here now becomes like this. The f of 2 is now 2 square minus 3 times 2 plus 2. Then minus, the f of 0 is now 0 square minus 3 times 0 plus 2 all over the 2 minus 0 here is simplified into 2. Simplifying the two big groups in the numerator, we have 0 minus 2 all over the denominator 2. So the numerator here now becomes negative 2. And when we divide this by 2, we simplify the equation into 2t minus 3 equals negative 1. Let us now solve for t. Let us transpose this negative 3 to the right side. That becomes positive 3. So we have the right side, negative 1 plus 3 is now simplified into positive 2. Dividing both sides by 2, we have t equals 2 over 2, so that t is equal to 1. This is our final answer. I hope you learned something from this video. See you again next time.